Assalamu alaikum. Hope all of you are fine. Today we will discuss about the fractional distillation, separation crude oil into different parts. I am Professor Dr. Muhammad Mehdi Hassan Khan from Sylhet University, Bangladesh. I am Professor of Department of Biochemistry and Chemistry. The fractional distillation, they separate crude oil into different, more useful hydrocarbon mix called fractions. Okay, so normally what you do, these are alkanes, different types of alkanes. They are made of carbon and hydrogen. They are hydrocarbon, and these hydrocarbons they have single bond. Okay, in the raw crude oil, they are mixed with lots of items. So we need to separate. So how the process works, because each hydrocarbon fraction has a different boiling point, which depends on the length of its carbon chain. So the process of fractional distillation, the separation is performed in a tall vertical fractioning column or distillation tower, which is hottest at the bottom and coolest at the top. You can see like this. This is actually the column or distillation. You see there is a crude oil that enters from here, and here this part is very hot. If you heat it, if you heat from the bottom, it will reach there, and those are volatile things. These will be in here. So you can see the crude oil is the first heated in a furnace to a very high temperature, like 400 to 600 centigrade, which causes most of the hydrocarbons to vaporize. The hot mixture of gas and liquid is pumped into the bottom of the fractioning column. As the vapor rises, it cools. So here is low temperature, and here you can see in the red part, they have high temperature. Now, the condensation. When the vapor reaches at a height where the temperature is equal to its boiling point, it condenses back into a liquid. Phase at different levels collect the condensation fraction. You can see these are the things. So the toppest, you can see these are the gases. You can see here this gas, liquid petroleum gas. So it is known as LPG. The carbon number 1 to 4. These are LPG. Okay. So the collected liquid fractions are piped out of the column. You can see these are the column are piped out. The column, the hydrocarbons with the highest boiling point remains as a liquid residue at the very bottom. They are in bottom. Existing gases, hydrocarbons with very low boiling points do not condense at all and exist as gas from the top of the column. Here you can see the gas is going here. You can see from here. See? Yes. The fraction obtained from the crude oil, you can see at the bottom, the hottest part, you can see this is bitumen, a black solid at room temperature, residue used for road surface and roofing. If you go in the road, you can see the black things they use to prepare the road. Those are known as a bitumen. This bitumen is come from this, you can see the road or roof bitumen. This is carbon number more than 70 or residue. Heavy fuel oil, viscous liquid as fuel of large ships and power stations. This their temp. You can see the carbon number from C20 70 fuel oil they use here. And then lubricating oil. You can see these are also lubricating oil. Carbon number from 22, carbon 50. Mobile or like these types of lubricating oil, wax and greases. High density liquid. So these are the things. These things are known as the bottom, highest temperature, highest boiling point. And now if you go in the middle part, you'll find diesel or gas oil, and top of this you'll find kerosene or jet fuel is here. Okay, and the petrol is here, carbon number 5 to 10, and the top you will find the naphtha. Naphtha is a chemical. So at the toppest part you will find petrol or gasoline. You can see gasoline or petrol here, and the toppest part is refinery gas, LPG, liquid petroleum gas, LPG, very high hydrocarbon, mainly propane and butane, that are bottled and used for heating and cooking. And the properties of the fractions, the properties of the fraction change periodically from the bottom to the top of the fractional column. boiling point decrease from bottom to top. So here the boiling point is less, here the boiling point is decreasing. Is high here and is decreases from bottom to top. Top their boiling point is low, and volatility. So increase from bottom to top. They are very volatile, and the top things they are less volatile. So volatile decreases from bottom to top, or you can say the opposite thing, increases from bottom to top. Viscosity, thickness, decreases from bottom to the thickness is high, very high. The viscosity, thickness is very high here in the bottom, and the top viscosity is lower. Flammability increases from bottom to top. They are more flammable than the gases. And carbon chain length. So here you can see the carbon length is higher and the top is lower. So it decreases from bottom to top. So now we'll go, there's another chapter known as modification of alkane by cracking. Crack means breakdown. So you can see in some cases, when the number of carbon is lower, their demand is very high. So cracking modifies large alkanes by breaking them into smaller, more useful alkanes and alkenes through thermal or catalytic process. This is done because shorter chain alkanes are more in demand as fuels, while the alkanes produced are valuable for the chemical industry. There are three main types: thermal cracking, high heat and pressure, catalytic cracking, catalyst moderate acid, and steam cracking, high heat steam. So now we'll go for types of cracking. Thermal cracking condition: very high temperature like 450 degrees centigrade and high pressure up to 70 atm. Products: a mixture of alkanes and a high proportion of alkene. Mechanism: use free radicals. These are known as thermal cracking. Now, catalytic cracking. Catalytic cracking, you can see moderate temperature is less than or about 500. That one is more than 450. So that means there could be 600 or like this. Here is near about 500, and the pressure with a catalyst like a zeolite or aluminum oxide. Okay, these are catalysis. You know the catalyst who helps in reaction. Now the products. Most gasoline range hydrocarbons, 5 to 10 carbons. They are branched alkanes and aromatic hydrocarbons. These are the products. Mechanism: use ionic intermediate called carbonium ions. Okay. Now we can see steam cracking. So there will be a very high temperature, 800 to 900 temperature, and low pressure with steam added to the feedstock. Okay. So a high proportion of alkenes. So as you know, alkane, they have single bond, and alkene means they have double bond. To dilute the organic feedstock, which prevents the formation of carbon. Why cracking is used? Cracking is used to produce more valuable product. Cracking converts large, less useful hydrocarbon chain from crude oil into smaller, more valuable ones. There is a higher demand for shorter chain alkanes, which are used as fuel than what is found in crude oil. Provide chemical feedstock. The alkenes produced are highly reactive and are essential raw materials for making plastic and other chemicals. So we already discussed about the thermal, the three types of cracking, like temperature between 500 to 950 degree, pressure up to 70 atmosphere. Mechanism, we already discussed the homolytic fission and the carbon-carbon bonds. Resulting, we discussed that they produce ethene and propene. Okay. And the catalytic, you see the temperature is about 450 degrees centigrade, slight pressure, and zeolite catalyst is used. The product: a high proportion of branched alkanes, cycloalkanes, and aromatic hydrocarbon. So what are the importance of these? These products of cracking is vital for petroleum industry due to the mismatch between the supply of different hydrocarbons from crude oil and the market demand for them. Balancing supply and demand. Fractional distillation of crude oil yields an abundance of heavy fraction with long-chain alkanes, but there is a higher market demand for lighter fractions, such as gasoline. Cracking allows refineries to convert the less valuable heavy fraction into more desirable light ones. So you can see in some cases, or not only some cases, most cases, those are short chain like gasoline or like these. These are more demandable. So we produce, or the researchers, they produce these things from long chain to short chain alkanes. Cracking is a major source of alkenes, which are essential for raw materials for the petrochemical industry. They are used to manufacture plastic, polymer, and a vast range of other organic compounds. Catalytic cracking in a particular product's branch and aromatic hydrocarbons that burn more efficiently are used to formulate higher octane gasoline. So like you can see, think that a carbon that has 10 carbon, taken. Taken can be divided into two. One is octane that has 8 carbon and ethane that has 2 carbon. Okay. So these are actually by cracking, we can produce this. So I hope you have understand. If you have any comments, please put your comments here. So thank you everybody for your passion, caring, listening. If you need any more thing, please ask me. Assalamu alaikum.